Okay, welcome back. Hope you can hear me fine. If you can hear me, just type in the chat. That would be handy. For some reason, oh, there we go. Okay, so it's all started. That's all good. This help session, I'm going to cover header files to start off with. Header files won't take too long, and then I'm going to cover the assignment, and if we have time, we'll talk about the exam or anything else you'd like to talk about. All right. Why is that not loading? Okay, that's a little weird. I'm just going to lower the quality of this. I do not need to watch the stream myself. All right, so the programs you've been writing so far have actually been quite small. Even the assignments, they are quite small. Now, when I say this, you have to remember that, let's say we're doing a graphics calculator or something like that. Think about what would go into producing that versus the code that you've written, or even an interface, or let's say a big program like, say, SolidWorks or MATLAB, or what's some other software that you use. So firstly, you have to consider that you'll be working with multiple people as well. Now, we don't do source control in the subject, but this leads on to source control as well. Further from that, we also are probably going to try and reuse code that we've used before. So if I was designing calculators as one of my roles, then I'd probably reuse the old version's calculator for some of the functions and update other parts. Further from that, you may use open source or licensed code. So a lot of code that's used, we don't just write it all. We'll use open source platforms or other platforms that are available, or we may actually buy code for certain things because it has to be licensed. So an example might be using an SD card. A lot of that stuff is licensed, so you can't actually use certain features without paying for it, and so you have to pay for the code. You don't have a choice. So this leads on to header files. Okay, now can you just make sure you can hear me, because my stream does not seem to be up. Can you just type in the chat if you can hear me fine? I'm just getting, or if it's lagging or anything like that. I'm getting a little bit of a weird mess here. Can you hear me? Just okay. Is it lagging? Okay. Can hear us fine. Okay. I don't know what's going on my side. All right. So I've got this code here, which you did in Lab 6. So this is your statistics functions and array functions. Okay, so I've got a fair bit of code here. Okay. And this is actually a fairly good set of code that could be reused anytime I want to do some statistics, or if I want to redo any array functions. So what I want to do is basically turn some of these functions into a library so that I can reuse them for other bits of code. Now, there is a couple of ways to go about this, and I'm going to show you the easiest and probably the most professional way to go about this for a basic level. We're not going to concern ourselves with folders and stuff at this stage, but there is more to this, and you probably need to look through the lectures. But what I can see here is that these functions here, well, actually, excuse me, all of these functions are some kind of array functions. Okay? But these first 5 are more general. These ones down here are also array functions, but they're quite specific. So they're stats. Okay? So what I'm going to do is create what is known as a header file. Okay? So I'm going to go over here. At the moment, now this is going to get big, so just be aware of that. My code is in, let's call it lab 6, okay, .c. So I'm going to create another file called array functions. Actually, I'll call it, just so that it's a little nicer, so that you know that these are our ones. I'm going to call it my array functions. And I'm not going to write .c, I'm going to write .h. Okay? And what I'm going to do is I'm going to grab, if I can find what layer it was on, that one. I'm going to grab these general functions and put them into here, just the prototypes. Okay? So that's all I'm going to put in there for now. And what I'm going to also create, now I've lost what layer it was on, which is great. I'm going to create another file called my stat functions, so my statistics functions. .h. Who's messaging me? Cool. Okay, and I'm going to move these into here. So I think that's layer 3. Okay, so I've got my header files. I've got 2 header files now, and in these I've got a bunch of function prototypes. Okay, my functions are still in this program here, which is perfectly fine for now, but doesn't make as much sense. This program won't work anymore because I've got rid of the function prototype, so it'll say this function is being redefined. So what I need to do is I need to include these. Did I need to do that? God, where am I? So these are all in the same folder. Okay, so labs 6.c, my array functions.h, my stat functions.h are all in the same folder. So we go hash include, and this time, because we're talking about the local directory and not the standard directory, we go double quotes, my array functions.h, and we go hash include my stat functions.h. Okay, so that's all well and good. My program will actually work now because this includes these definitions. Okay, so these definitions are part of the code, and so these are defined before we use them. But this doesn't really help us that much because, well, my functions are still in this program. So including this didn't do much. So first thing I'm going to actually do is I realized that my stack functions are actually a subset of the array function. So I'm actually not going to include this here, just to show you how you can go from one function, one to another. And I probably should indicate the title some way different. So let's do that as well. Let me grab some blue or something. So this is the name of the file. It's not in the code. Okay. Same with this. Okay. So what I'm going to do is I'm going to grab this. And I'm going to move this into here. Okay, I might clean that up a little bit. So I'll just grab layer 2 somewhere. No, layer 6. I don't know what happened to layer 2. It disappeared. That's not that layer. It's that layer. Okay. So I've now got hash include my stat functions in my array functions. But in my main program, I haven't got that. Okay? So I've only got hash include my array functions. So when you include a header file, it's also going to include my stat functions. So I only need to include my array functions, and it'll include all these prototypes. However, now what I want is portability. So this is well and good. And the other thing which I haven't got here, but I should show you, if I put a hash define, let's say pi is 3.14, then I can use pi in this program as well, okay? And do something with it, all right? Because it's included, okay? Even though we've got pi from math.h as well. That's just an example, all right? Does that make sense so far? Okay, so in a header file, you can't put code, but you can put definitions. So you can have variables, so you can create variables, and you can create macros, and you can have includes. Okay? All right, but you can't actually have the code in that because you can't compile or a header file. But you can have the definitions too. So you can also have struct definitions in here, a whole bunch of stuff except for header files. I mean, except for code, sorry. All right, now what we need to do is we've got these function prototypes. What I want to do now is create a new file. So I'm going to call this file, and generally I will go about this way, and I recommend you do the same thing. And I'm going to call this my array functions.c. Now I give this the same name as this. Then I go, so this is the name of the file. Then I go hash include my array functions. So you'll notice that this one and this one have my array functions.h. Okay? Now these don't have to have the same name, but I think it just helps with when you've got a large amount of code, it'll make it a lot easier. So what I'm going to do now is go down here. I'm going to find my array functions. So not my statistic ones, just my array ones. And I need to find out which layer these are on. Not on that layer, they're on that layer. So I'm going to grab these. hopefully I'm in the right place. Yes, I am. Cool. So now I've got my array functions in here. Now, these are all in the same folder, and I'll show you how you have to compile. Where did my blocks go here? All the layers are visible. Okay, that's weird. Let me just draw them back up. Wait. Did something else. Done something stupid. Alright, I'm just going to quickly draw these back up. So this was my stats functions .h, and this was my array functions. I know what I did, and I probably shouldn't. No, that's an okay layer. They were linked on the same layer, this and that, and I've moved them. That was stupid. Okay. And this is lab 6.c, and we had a hash include here. My stats functions .h, and in here we had hash include my array functions .h. Okay, so it shouldn't be .c here, it should be .h. Now, what we notice is that we've got the definitions here, and this C file has these prototypes, and you'll notice that this C file has these prototypes. Okay? Now, when we compile, these will be linked because they have the same prototypes. So the definition of selection sort is found, it's here. You'll notice that the lab 6C is the only file with main in it. Okay, you can only have one file with main in it. So this is our main. All right. Now what I want to do is do the same with my stats functions, and I want to link them up. But you'll notice that they're not being linked from here. They're being linked from here and then to here. Okay, so they go a couple of levels. I should have had the arrow the wrong way around. Okay, so the last thing to do is just create my stats functions dot C, and I'm going to grab this last layer, and hopefully it's not the one that I've drawn on. Okay. Now, so yes, I have all the definitions now. However, this still won't work. Okay? It's very, very close, but it still won't work. Now, one other thing I'll add, if you do not want your functions to be global, meaning everything to access them, so you'll notice that in my array functions, at the moment, it can only get, well, it can get everywhere now. But you'll notice in the stats functions, it can't access any of the headers. And I forgot to hash include. my stats functions H. Now this is the fun part, and then layers of bit are linked. This is the problem with doing it this way. Delete that. Cut. Move it down. Okay, that's better. Okay. So I've got hash include. Sorry. My stats functions .h. All right. So we've linked everything up, but there's a couple of problems here. So these functions here only have access to this because it's the only thing that's included. However, my array functions has access to this and my stats function. So it has all of them, but my stats functions only has access to this here. All right. So let me get rid of that arrow. Too many layers. Get rid of all the arrows for now, and we'll see how it works on a smaller scale in a second. See if I can work out what freaking layer I'm on. Oh well. I don't know. This is it. All right. Okay, so as I said, the mystats function.h, I'm going to read in my arrows so that make a little bit more sense, only includes this. So it can only get here. Okay? My array functions.h can go in here, and my include can go here. All right? So it can get to here, and this one can get to here. So you'll notice following the arrows that my stats function can't get any of these because it doesn't have a way to get there, right? Following the direction of the arrows. Now, we'll notice when we get down here that we need selection sort. Okay? So we're going to have to get to my array functions. So I need another hash include here. Okay. Now, this has a connection to this. Okay. Even though this part will be included twice, that's fine. That's perfectly fine, as long as it's got a link to this. Okay. So actually what we can do now is get rid of this, because we'll notice that my array functions is part of my stats function. So I can get to that file from there. So I can actually get rid of that if I wanted to. I would probably personally leave it in there. It's not going to hurt, and it just is a bit more complete. Now we also have some other problems. So here we also have somewhere in the distance standard IO.h and standard IO.c. We have standard lib and so on. Now, these are accessed from here, all right? But this function doesn't have access to them. And you'll notice that this function needs how. So it needs the maths library. So hash include math.h. Now, we could also do this in here if we wanted to, or we could do it in here. If we do it here, it means all of the functions have access to these libraries that include this, where this means only this one has the math.h library and this one, but this one doesn't. And we can basically block off stuff. So if I only want a function to work inside this file but not let main have access to it, then I create my function prototype or my function just in here rather than in a header file. And you'll see this in the lab, not this week, but the following week. So do I need anything else? Yeah. Yes, I've got free, so I need standard lib as well. So I need hash include standard lib.h. Okay, you notice that I'm using these brackets and not these brackets. So these brackets are where there's local things. All right. And in this one, we have scanf, so we need hash include standard io.h. We also have malloc, so we need hash include standard lib. I don't think, is there any math in here? I don't think there is. No, I don't think there is. So you notice here, I don't need the math library. Okay, and my array of functions.c doesn't have access to that. Okay, this function does, and this function, this file does, and this file does. If I put hash include map.h here, then this would have it, this would have it, and this would have it. But this doesn't need it, so I'm not going to include it there. All right. Now, if I run this program, it should work perfectly fine. However, how do we compile this? So basically it follows the same process as before. We want to see all the warnings. I want an output file. Let's call this output file just A out, just because the next part's going to be a little bit long. So I then have lab.c, because I don't compile header files. I then put my array functions.c, and then I put my stats functions.c, and I need to link the math library as well. So you can see, and this is where make files come in handy. I don't think we do make files anymore in this subject. There might be some supplementary material on it, but these can get really long, and so you create what's called a make file that will do the compiling for you. Because, yeah, these could be very, very, very long. So here we've got my array functions lab.c and my stats functions.c. If you have multiple files with main, it won't compile. Each one of these has to compile, and they have to compile together. Okay. Now, if I write another bit of code, so in my folder right now, I've got lab6.c, I've got my array functions.c, I've got my array functions.h, I've got my stat functions.c, and then I've got my stat functions.h. Now, generally, this wouldn't be the best way to go about it, because these are all in the same folder. So what you generally do is this folder I'd call my array functions, or something, I'll just call it my arrays. Okay, and in another folder below it, I'll have lab 6. Now I can just specify the path and have my arrays slash my arrays slash my stats functions. And I have to do the same here. So I have to do my array. Obviously, this will be on one line. My array slash. So I can specify a full path in the include. Okay, so I can specify the folder it's in and so on. Now, if I create another program, let's say it's called array fun, okay, .c. Then I can just rewrite this, and because these are in folders, I can just go write array fun, okay? And this would just include, in this array fun function, it just include my array slash my array functions. Okay, and that would give it access to all these statistics and array functions that you created earlier. So let's have a look at this, just in a little bit of a cleanup way. Maybe I've made this too messy to even get there. All right. This is going to be hard, but we can do it. So I'm just going to make a cleaner version of this without all the code. So what I'm going to do is move myself over here. And we'll create two boxes. Now, I'm not going to bother with the folder. Maybe I will create a folder. So this here is the folder called my array. Okay. And in this, I have my array func.c, my array func.h, I have my stats func.c, and I have my stats func.h, and in here, I probably should have made that one bigger. I wonder if I can just stretch it. Give me a second. 2. And what I'm going to have here is just lab6.c. Okay, and then over here, I'm going to have math.h, and I have math. I'm actually not going to have math.c because it's a bunch of libraries, but I'm going to have math.h, and I have standard.io.h, and I have standard lib.h. Okay, and I'm not going to worry about what they include. So these are the standard libraries in standard directory, and this is in my directory. So it's called my dir. Okay. So what I'm going to do now is just add everything. So we've got standard IO, standard lib, and math.h. So we've got standard IO here, we've got standard lib, and we've got standard, no, we've got math.h there. So we've got math. And we've also got my array functions. Okay. We then, in my array functions, have standard IO, standard lib, and my array functions. Standard IO, standard lib, and my array funcs. I should indicate these are header files. The rest of them are C files. Okay, so I'll put them in yellow or something. So the yellow ones, that's a horrible color. Are header files. And my stats function has standard lib, math.h, my array functions, and my stat functions. So we've got standard lib, math.h, and my array funcs, and my stat funcs. And in here, we have, well, we should be a hash include. No, there shouldn't. In here, there should be a hash include my stat function. So in here, we have my stat function. Okay. So these are all the linkages. So I'm just going to draw them out now so we can see where everything goes. So this one has access to standard IO, standard lib, math.h, okay, and my array funcs.h. Okay. So you can see that these .h's are linking these files. Okay. So standard IO would be linked to something else. Standard .h, math.h will also be linked, but I'm not worried too much about these. And this one links to here. Then we have standard IO here. So this one can go up here. We have standard lib, so this one goes up here. And we have my array funcs, so we have this one here. Now you'll notice that if I had extra functions in Lab 6, none of these, my array functions and my stat functions, could access them. But because of the way they are included, this has access to all of these. And my stats functions also has, well, we'll see in a second, has access to all of these. So this also has access to standard lib. It also has access to the math library. This has access to my array funcs. And this has access to my stat funcs. Okay, so if you follow the lines, you can see what has access to what. Okay, so for example, this here has access to this, okay, and this has access to this, and this has access to this, and so on. And because these definitions match, we've basically linked them together. Okay. But because lab 6.h is not defined, or there's nothing linking this back, we can't access any functions from in here. Does that make sense? It can get fairly confusing, and there's lots and lots of tools to help with this, and most IDEs will do this automatically. So you don't usually have to worry about a lot of this, especially when your program gets very complex. And as I said, you'll have make files. But for something simple, we've only got a couple of files. This can be quite handy. And I would personally, if I was you, do it with your array functions, because they can be quite handy in the future. Because it means that now all I need to do is just take these with me. All I need to do is take this folder with me, and I can use it with any program now. Okay, Does that all make sense? Is there any questions? There is a couple of other things like extern and stuff like that, but you can read the lectures about that. This is the main thing that I want to get across. Sorry, there it is. That's the subject. Okay, so James asked a really excellent question. And why don't we put the prototypes with the definitions? So if we put the prototypes, I can't move that. It's about 3. So if I grab these prototypes and put them in here, so inside this file, now these are local, meaning only this function can use these prototypes. And my main function, I call this the main function because it's the one with main, can't use these anymore because there's no linkage. The other way around, I can't include these bit of code into the .h because .h's won't compile. And so the code will never run. Okay, so if I move these here, and you'll see examples where some of these will be in here, and some of these will be in here. So the ones that I don't want main using, so there might be some steps inside that just run inside these functions, then I'll have the prototypes in here. Okay, but the ones that I do want main accessing are in here. And so you can split these up so that some are local and some are global to the project. And you'll notice that here, this has no access to maths library. Okay, so we can limit what things have access to what, and it actually can be quite a good way to control things going on. Okay. I'm pretty sure we did this last week. Okay, so I'm going to get some questions up. So let's chuck some quiz questions up. And then we'll go on to the assignment. That one. I've got this one. This one's an easy one. I've got. Oh. These are all kind of easy. Hard questions. Yes. I'm setting some quiz questions up to review some of the content from last week. That's a tricky question. Get all the questions up. Ah, space. That's a better question. Sorry, I'm just trying to fit some questions on the screen. Yeah, that'll do. So that's the answer. Which doesn't help. Okay, that's enough. That'll do for now. I'll grab the other one in a second. All right, so I give you those 3 quiz questions. I've got another one, but I can't get it to fit on the screen. So we'll come back to it in a second. So have a go at them. I'll be right back. And anyone that's up to this point, just skip ahead so you're up to the same spot. Or take a break, have a drink, whatever. All right. So if you're watching, please use the chat and try and skip ahead so that you're doing this with us. So we can have a look at these here. Now, we can firstly rule that one out because file open is not a function. Now, we can also rule this one out because we know that the definition requires a cast star and a cast star, and that second one is a variable. Now, that variable could be a pointer to that string. It's to a string with that, so but that's not defined beforehand. So if you had something like, let's say car R2 becomes the string R, this would actually work because that's a cast star, but we're not going to get into that because that hasn't been defined, so we'll ignore that. Read is not one of the options for F open. And then we have R plus and R. Now R plus allows reading and writing, so it says reading only, and so that leaves us with C. Okay. This one here, you all got wrong. So let's get up the definition of F puts. So the definition of F puts is a cast star, it's actually a constant cast star, and then the file. Okay, and that's the definition. So this would be string and this would be file or whatever. So these are in the wrong order if it was B. So that's ruled out. Okay. If it was the other way around, then that one would be right. This one is wrong purely because there's no, it says file pointer, the meaning of life is, and there's no format specifier. Okay, so this one can't be right. Okay, because it will just print the meaning of life is. And you'll probably get a warning saying too few arguments. Too many arguments, sorry, other way around. Now this last one is wrong because this is not a string. And that leaves D and A. So let's have a look at the definition of F print F. So the first thing has to be the file pointer. Okay, and then we have our string. So this one can't be right. So we have a look at this one. We've got the file pointer, and then we have the meaning of life is %D. Because it's a formatted print, it'll put a 42 there, and it'll print the meaning of life is 42. So the answer is A. Okay. With printf and fprintf, they work exactly the same, except for fprintf has the file name here. So, these are exactly the same now, because standard out is the screen anyway, and printf always goes to standard out. So these are equivalent, okay? And you can see printf and fprintf do the same thing. because this is a formatted print. That's what the F stands for. Whoever says function at this late in the subject, considering this was done in week 2, none of these Fs will stand for function. So this is file print F. Print formatted. Okay? File print formatted. So it's A. And this last one, everyone got the answer, which is A. And you can see that it follows the same format the file pointer is at the start. Okay, so I just want to get up the last question that I had here before we go on to other stuff. What have I done? Okay. I want that. What's that? Okay, so I'm going to give you another one. Let's work it. Okay. Have a go at this one. I might make it a little bigger. A little bigger as well, just so you can read it easier. So, so we're going to E. So put down what you think. Given you're going to be in an exam soon, so you have to make an educated guess. Don't just put in nothing. So there's another. Okay, so we've got another E. Have you got any more answers? Right, what do you think? Let's see who's watching as well. If you're here, please contribute. That makes it easier. we got any more answers? All right, so E is not the answer. I can tell you that right now. All right, so let's have a look at this. So we've got a character array, we've got an int, we've got a float, we've got a file pointer. We open a file, all good, we all know how that works. Then we've got this fput. So in our file, we put numbers, numbers, 5.2 with a space there, and then a space here, 2.2, and then a new line. So our cursor's currently here. Okay. So we've done that. We use rewind, so now we're at the start again and our cursor's here. Okay. And then we scan. Now this is normal scanf, and this is something that was in the reading notes that you need to be aware of. So if scan from the cursor, so the first scan will find the first string, which is numbers. Okay, and %s does not include spaces. If you want to include spaces, you need to use fgets. So we get numbers. So numbers is stored in here. Then our cursor is currently here. So we scan for the next integer value, decimal integer. So the cursor goes across, it finds the dot, so the first integer value is 5. So the 5 goes into the int. We then are looking for the first float. So it scans and it finds 0.2. 0.2 is a float. So we have numbers 5 and 0.20 when we print this out, because this is 2 decimal places. Hence, A is the answer. Does that make sense? And I would recommend you remember this. Okay? Okay, and it was in the reading notes, this stuff, very early on. But this time we're just talking about files. And as you know, the screen is like a file, so they act exactly the same. Okay. Now, what I wanted to do is just quickly. No, I'll leave that. All right. So, have we got any questions so far? So, do we want to look at the assignment, or do we want to look at more exam stuff? So the assignment, I just put up a short extract of one of the videos up on LMS. So there's quite a lot of information up on LMS for assignment 3. So you've got this short 10-minute video on 2D dynamic arrays from a couple of weeks ago. That should be enough to help you with that. You've got 2 videos with the example outputs, with and without the bonuses. And they should work the same if you're using LATCS5 and you haven't seeded your pseudo-random number generator. Okay, I've got a bunch of test data here for you, which you can test and run. So if you open this up, you can find out what they are. I did write some AI to do this, so some of them aren't a human player, but rather AI playing. And that's how I get so many test cases made. And they are actually playing the game. They're not cheating. And you'd be able to tell the difference. Then we've got the submissions, and the bonuses are all here as well. Okay. So, do we want to go over the assignment, or do we want to go over the exam? Or neither. Hello. We just covered header files. It's not for another week that we'll do that, but I'm now asking if you want to cover some information about the exam or the assignment. So I had another question just here. How do we check for the size of the string? So if you've got hash include standard, right, .h, if you're just waiting for me to ask a question if you want to go over the assignment, please don't. It's kind of rude. Please participate in everything. There is a function called string length. So we can pass a string in here, so a car star, and this gives us the length of the string, not including the null terminating character. So if I had some string in here, let's just call it str, and I store it in int a, and the string was hello, it will return 5. But the number of characters is actually 6, so don't forget that. This can actually be quite handy to use to add to a string. So I'll just quickly show you a quick example. So let's say I've got a string, let's say car a 40, and I initialize this to hello. Okay. Now, all the rest of the characters are null terminating characters. So I can do something like this: int b equals string length a, and I'll get 5. But what I also can do, which is kind of fun, is I can add to this string quite easily. So I can go a string length a becomes, let's say, w, or something like that, and that'll add another character to the end of the string. Because A5 is not this character, it's the null terminating character, so it'll replace it with a w, so we end up with hello w. Okay, so that's just an example. But just to straight my new screen stuff this way. All right. So I'm going to cover the assignment. I'm not going to give too much away because yes, ideally you are working on stage 2 by now. So stage 1 should be done. Stage 1 is practically the same as the last assignment. There's nothing new in stage 1, and anything new, like RAND, I've given you the code. So stage 1, we aren't really testing any new knowledge, so it's not worth much. Compared to the other stages. Okay, because it's fairly easy. It's nothing new, and yeah. All right. So let's have a look. So one thing that some people forgot is the standard lib library. Don't forget it. You've got your function prototypes. Okay. Now, one thing you need to remember is when looking at these function prototypes, you have to look at these stars and realize that, okay, this get move function, for example, I know these here, these first 3, are going to pass an address in or a pointer, which holds an address. Okay? And I know these 2 I won't. So when you see a star, you need to remember that there's going to be a pointer passed. And don't just guess and chuck a million N's and W's and random stuff until it works. All right. Implement the first 3 functions from above. So initialize mine bullets, initialize mine values, and make move. So they should all be done by now. You've got 2 structs. You've got the location and the game. So we might have a look at this location and game just to understand Minesweeper a little better. Now, create a global variable. If you call this global or globe variable or something like that, you will lose marks for naming. Okay? I don't call a local variable. I give it a meaningful name. Okay? So make sure that you give this still a meaningful name and don't call it global variable. Because if I was writing code and I had int main local variable, int local variable, what are we going to call everything else? And it's not very useful. Okay? So don't call it global variable, please. That's not what I want to do. Now I've lost what I was doing. Okay, define a macro. Name mine as value 0, flag as value 1, and revealed as value 2. Everyone's done this pretty well. Don't forget, do not put a semicolon after the value. Okay? And these are to be used as bit flags for the status byte. Okay? So let's have a look at that. Now this is something you've already done before, but without macros. So I'll copy this across. Okay. So this part here, now obviously we're not doing it at this stage, but is exactly the same as the bit lock thing, except for we're using macros. So we've got mine defined as 0. I'm not giving you how to do that, but you can work that out. We've got flag as a 1, and so on. You've got a status byte, okay, which will be a car. And this basically has 8 bits, okay, because it's a byte, or a car, which is a byte. Now, we're only using 3 of these flags, so these top ones we don't really care about, okay? However, initially we set them to 0, but we never really cared. It wouldn't really make a difference if they were 1s. The bottom 3 we do care about. So the 0th flag, which is mine, if it's a 0, then it indicates that there's no mine. If it's a 1, it indicates that there's a mine. The 1th flag indicates if there's a flag there, a 0 if it doesn't, and this one will indicate if it's revealed. Okay? So for each location, there is a pointer to that location, and that information includes a status byte and something else. I can't remember what else. Oh, it's value, sorry, and it's value. Okay, and so while we're playing the game, if this is a 0, then you can't see anything under here. And when this becomes a 1, then you can see the value, let's say a 6. Okay, so the value is a 6. All right, but while it's a 0, it's hidden or unrevealed. Okay, so how we change this is pretty much like in that bitwise lab. We can do set, clear, toggle, and we can also do test. Okay, so if I want to set this first bit, the mine bit, if we remember, we can just go status, byte, or 1 shifted mine. Okay, and that'll set this 0 bit. Okay, so you've got all these on that lab. So you can do testing, you can toggle, you can clear, you can set, and you can do as much as you like. Okay, does that make sense? So you've got all that information already. If you're here, please say something, see if it makes sense or not, or doesn't. Just say yes, thank you, or no, it doesn't, whatever. Because I know there's quite a few people here. Okay. So just refer back to that lab where we did the bit lock, and you can do exactly the same things with this status byte. All right. All right. So let me grab the lab back up. If is it? There it is. All right. Now, it might seem funny, it might seem stupid, but I am going to emphasize this point. This needs to be done in this format. There is no spaces, there are no tabs. This is the start of the line. Now, someone has actually written this. This is your name. Okay, and this is your student number. Okay, please don't write John Smith. All right. And that comment shouldn't be there. But you can ignore that. Right? If you put John Smith there, you won't get your assignment marks. All right. We all know how to create a struct now. Now, one big thing, that is a type. If I see these two words separated anywhere, then I won't be happy. Okay? Yes, it's funny. I was not laughing. Well, I'm probably laughing a little bit, but I wasn't laughing after that. Just created more work. Okay, so please don't. Okay, with your structs, once you've got your variable, you do not need to use the name of that variable anymore. I mean the type again. Okay, just use game. Right, struct game has already been used. It's when it's declared. It's the same with int a. We don't write int a after that again. Okay. Go back to the struct lab if you want to review it, or go to the struct lectures. Set both the mines flags and flags variables in the game struct to 0. So we know how to do that. Game dot flags. So I had a good question, and that is, if I add a title, will you lose marks? So possibly. So part of this, and the reason the assignment is set up like this, is not only testing your ability to code, it's also your ability to follow a standard. So if I've requested a particular format, then you don't know what it's used for. If your client requests something in a particular format, you should never ever go outside of that standard. So adding titles or funny jokes or extra things always get picked up because they don't follow our script, and you don't know what we're using your code for. And this is a perfect example. Your code runs through a script, and so it breaks the script. And so because you went against the standard, it doesn't work as intended. Okay, and you're unable, we're unable to use it. And if this was a real world piece of equipment, this could be dangerous. Okay, and it's something that happens a lot in the real world, because people want to show off their skills rather than follow the specs. So you shouldn't add things like titles and things like that unless it says be creative, or we want you to design something that's creative. If they give you a specific spec of what's to be printed, there is a reason for it. And you'll notice that we are being very specific about the spec. So even when we do give you options, it has to be one line, ending in a new line, and you can choose an appropriate message. Okay? But this needs to be spec. All right? So unless it says add a title, don't. Okay? Because you're just breaking the specification. And this does happen in all kinds of fields, not just programming. Okay, all types of engineering, all types of computer science. If the client wants that, they will ask. All right. So don't forget your dot operator. I'm pretty sure flags isn't a pointer. Okay. No. So dot flags becomes 0 or 1 or 10 or whatever. Don't write struct, don't write game here. They're not the same thing. All right. Ask the user for the width and the height of the board. If you don't know how to do this by this stage, I can't help you. Ask the user for the number of lines and store in the game variable appropriately. Now, when I say all this is something that you want to debug, okay? Make sure it actually works. It's very simple, it's easy to debug. Make sure it works before you go on. Because if this doesn't work, then nothing else is going to work. Same with these 2 lines. If step 6, which is a lot harder, isn't working, and you've got something wrong with 4, you'll never know because you didn't debug it. All right? So debug these early steps so that some of the hardest steps aren't impossible because they can't work. Right. Step 6. Create a pointer to a pointer. So a pointer to a pointer is a double star. A pointer to a pointer to an int. Okay? So it's a double pointer. All right? This here is saying a double pointer. But double pointer doesn't really make any sense because what's double about it? It's a pointer to a struct. Location, name line board. Okay? And dynamically allocate the memory of size, game, height, blah, blah, blah. So we get a big array of pointers. And then we get a whole heap of, where's the rest? I need to copy it, sorry. That would help quite a lot. The explanation provided on this is that 10-minute video as well. Okay. And then iterate across these pointers. So you should have size of game height 2, so a bunch of these pointers. Size of height +2. And then each one of these is going to point at one of these. And we did this in the last assignment. So you just end up with a bunch of arrays and arrays and arrays. Okay, and then you can just use square brackets to go. This one is referring to this, and this one is referring to this. And so you can get to anywhere in your table. Okay. Are we happy up to that stage? Step 8 and 9, function calls. Okay. Initializes the board using the appropriate function. Okay. So why we're plusing 2 actually comes into, so why are we adding 2 is actually a good question. And we'll see this in a second, but our board actually looks like this. Okay. And the game that we see is in here. Okay. Now, when we get to step 3, stage 3, having this outer border helps a lot with the recursion. Okay. So in the first couple of stages, you won't really see the purpose for the +2 because you'll only see the game inside here and you'll ignore all of these spots outside. But your game board has this hidden border, okay? And we'll talk about this hidden border in a second when we talk about initializing the board. So let's go. So obviously this is initialized board and this is print function. So let's grab this visualized board. Make sure you draw. Why do I keep doing that? I did that on the last thing I made. Drew a big line across it. Make sure you draw a box and pointer diagram when you do a function call, because a lot of people are still doing function calls very wrong. All right. So create some iteration variables, blah, blah, blah. Iterate from 0 to gain height plus 1 inclusive. Okay? So we're going from the 0th all the way to gain height plus 1, which is down here. Okay? We are then going from 0 to gain width plus 1. Okay, so this is our board. Okay? Because normally, when iterating over a two-dimensional array, we'd be going, well, knowing what we know about arrays, if I had an array of n, to iterate it, I go from 0 to n minus 1. But because it's plus 2, we go from 0 to gain width plus 1. Okay, because we had 0 to n plus 2 minus 1. All right. Does that make sense? Why we go from 0 to gain width plus 1? Because we have this hidden border and we've added 2. Okay. Set status byte for 0 for every location. Okay, so we're iterating over our array, so this thing, which we can imagine looks like this. Okay, so we don't have to think of it as this ugly pointer thing. Because we've got these square brackets, we can just treat it like it's this. Okay. Now, you'll notice that the y is first and the x is second. Okay, the reason is because the width are the rows. Okay, and that's done second. Okay, so the x goes across, and so the x, it's not xy, it's yx when we refer to the array. And I did give you that in 5b just to make sure you weren't doing it backwards. All right. So if I wanted to refer to location 1, 1, oh, sorry, that's a really bad example. If I want to refer to, let's say 2, 1, where this is x and this is y, then this would be location 1, 2. And because we're talking about x, we go across to 2 and down to 1. So we're talking about here. However, when the user's using this game, they don't consider this 0. But we notice that it doesn't matter because our game board, so this part in here, starts from 1. So we don't need to do any conversion. So that's also another advantage of having the board like this, is that we can start it with a natural 1. So we set the status byte to 0 for each of the locations, which makes sense because, I don't know where I put that stuff before, because none of them are flagged at this stage. None of them, what were the flags that we had? We had flags, we had revealed, and there was mine. So none of them are mine, none of them are flags, none of them are revealed at this stage. So we just set every single one to 0. Okay. We happy with that? It's all good. Cool. Create a couple of variables and initialize the game lines. Okay, create variables x and y. So this rand function will just generate a random number, and this modular this mod operator will basically, so if we have, let's say rand here, and I go mod 10, this ensures that all the numbers will be from 0 to 9, purely because this is the remainder function. Okay? So if this comes out as a 9, I get a 9. If this comes out as, let's say, a 330 at 9, then I get a 9. If this comes out as 1,309, I get a 9. So it always gives me a number between 0 and 9. So adding this mod, or remainder function, allows me to limit my rand from between 0 and something. Now, if you want negative numbers, you need to do a little bit more there, but we don't need negative numbers. So we want a number from rand to game height plus 1. So we're basically saying that we want numbers between here, because we're adding 1, and here, and here, and here. So you can see we're not touching this border region. We're only playing in the game field. And we keep iterating. So we can see this as a loop. And we basically, let's say rand gives us 4, 3. Okay, so y is 4 and x is 3. So we test, we go to y 0, 1, 2, 3, 4. And we go x3, so 0, 1, 2, 3, so we end up here. Okay, and we test, is this a mine? Using this line here. So mine board, and we're just doing a test, and we're just saying not a mine. And if it is, then we just set the mine bit, okay, and decrement temp mines by 1. So just go temp mines minus minus or something like that. Now, this is what we talked about before, all right, when we talked about bitwise stuff. And then call the initialize mine values function. So that's fairly self-explanatory. It basically gives you the answer. Are we all happy with that? Please let me know if you're up to that stage. Okay, I'm going to have a quick break. I'm talking for another hour, and then we'll go over the next function. And then we'll start looking at stage 2. So I'll be right back. I won't be very long. Just need to stop talking for a second. All right, I'm back. So let's do this. We're up to. Let's this. All right. So, where it will be in a lecture theatre. I'm just confirming all that at the moment. So sorry, I probably should keep this for the recording. So I'm organising a bunch of mock exams. The exam will be very similar to the real exam, so you do not want to miss it. Basically, you'll get the same amount of time, so the exam conditions for 2 hours, and you will do an exam. Then you'll have a half an hour break, and then we'll have 2 hours to go over the answers. And there'll be 3 sessions, and you can kind of attempt. What I recommend you do is you come to at least 2 sessions. So you do the first session, and you get like 10% or 20%, or hopefully more than that, but and then do the next session and do better the second time. No, it's not, because we're using it for the mock exam. So you need to come, because you'll get a copy of it. Yes, that's during swap back. Last year's is not on LMS. It shouldn't be. No, it's not. The ones that are up on LMS are very different from this year's and last year's exam, okay? But they are very helpful as well, okay? However, you need to be aware that they may include content that's not included in the subject anymore, okay? All right, let's continue. Where were we? I don't know if we can record it. I'll have to find out about Echo. I doubt it, because it's not part of the timetable, but we'll see what we can do. We can bring a phone in or something to record it. How does that come up so small? That's crap. So the ones on LMS aren't similar, but the one we'll do in the practice will be very similar. It's pretty much the questions will be very similar, and there's slight variations. There's major variations, but the format will be pretty much the same. And there's things like box and pointer diagrams and stuff that's not on the previous year's exam. All right, so where's my pen? All right, so now we need to initialize the mine values. So I might just get a simple, it's going to be, hopefully, let me check my email. I did send it off to request it. What did I say? I said, now this is, if I can't get the room, then this won't be it. But I asked for the 30th, the 31st, and the 1st from 10 a.m. to 3 p.m. Okay. It won't be 5 hours. We need half an hour to set up and stuff like that. But yeah, it'll probably be 10:30 to 3 p.m. with a half an hour break in between. Okay. And that's Tuesday, Wednesday, Thursday. But as I said, that depends on the room, so these dates might change. All right. So I've got some back here, I'm going to get rid of. So now let's have a look at this stage. So I'm going to draw my line board up again. I'm just going to do a simpler one. So this is a 4x4. Okay. And as you can see, it is a 4x4, but we've got the +2. So the width and height is a 4x4. So the user entered a 4x4, and we're going to iterate from 0 to gain height +1, gain width +1, and 0 to gain height +1. So we're going to go over the whole board. If I, okay, so I is talking about the height one. Okay, that's I. This is J. Let me be on a higher layout. And this is J. So if I is equal to 0 or equal to gain height +1, or J is equal to 0 or J is equal to gain width +1, then set the value of the ij coordinate in the mind board to 0. So we've got this dot value. Well, it may not be a dot depending if it's a pointer or not. Actually, it is a dot, so it doesn't matter. So 0, which we can see is right there. Okay. It's not a pointer, so we don't have to worry about that. So we're basically just setting all the ones that surround as zeros. And this is purely for stage 3 that we need to do this. It doesn't help you with the other stages because you don't really care about this at this stage. Okay, so we're just setting all of them as zeros every time. And we set the revealed bit to 1. So these are, all the revealed bits for these are a 1. Okay, so these are revealed. And we saw how to do this for a mine, so we should be able to do this for the revealed as well. And we also have all these, and some of these will have their mine bits set. So let's say these 3 have their mine bits set. Okay, so it's a 4x4 with 3 mines. Okay. Else, create a variable named count. Count the number of mines by checking the mine bit of all locations that surround I and J. So if we are here, then we can check this one, 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 and this one. Now, you don't actually need ifs here if you do it correctly, but if you want, you can use ifs. If you're good with your bitwise operations, you can actually do this in very few steps. Else you can just use ifs. But if we're here, I is currently 1 and J is currently 1. So this location here is I -1, J -1. Okay. This one here is I -1 and J. This one here is I -1, J +1. This one here is I, J -1. This position here is I +1, J -1. This one here is I +1, J. This one here is I +1, J +1. And then this position here is I, J +1. Okay, and that'll give you all 8 surrounding pieces. Okay, so they're the 9 checks that you need to do. So if we check all, not 9, 8, sorry, they're all the 8 checks we need to do. So if we check all of these, We check this one first, we get a 0. We check this one, we add 0 to that, so we get 0. We check this one, we add 0 to that, so we get 0. We check this one, we add 0 to that, so we still get 0. We check this one, we add 0 to that. We check this one, we add 0 to that. We check this one, we add 0 to that. And we check this one, it has a mine bid set, so we add 1. We add all these together, and we get a 1. So this location now has a 1. So we keep going, and we do this to all of them. So this one would come out as a 1 as well. This one would come out as a 1 as well. This one would come out as a 0. This one would come out as a 1. And then we get to this one. So we'll do an example of this one again. So here, we check all the ones that surround. We also check the one with the mine. So this would be a 1 because it doesn't include itself. Okay. You don't actually have to check this one, but in this code we are. So it does have a value, but it has a value of 1. So just be aware of that. So now I go around. This doesn't have a mine, this doesn't have a mine, this doesn't have a mine. This does, this doesn't, and this does. So this would have a value of 2. This one has a value of 1, 1, 2, 2, 2, 0, 1, and a 2, and a 1, okay? Because it doesn't count itself. All right? And that's basically all we're doing in that initialize mine values function. Okay? Load already. Load. Does that make sense? Say yes or no. Say yes, please. Thank you. Whatever. Okay. Now, you can use ifs, but as I said, there is, because these are all just bitwise operations, and these have a 1 inside them, you can just use bitwise operations. You do not need to use if statements to do this. All right. Okay. And that's pretty much stage 1 done. So that's pretty fun. Okay, and there's nothing too difficult there. Now stage 2 is where the fun starts. So what a lot of people fail to do, and this is why it's highlighted, so once you've got stage 1 working, make a copy, okay? Because you can always go back to a state in which your program works, okay? So do not forget that, okay? Make sure you save a copy. And if you want to submit multiple, I don't mind, okay? Then declare variables for flag, X location, and Y location as appropriate types. So flag is purely going to be a 1 or a 0. So you can choose an appropriate type for that, not a Boolean type. The X location is an index and the Y location is an index. So it's only going to store 0 to game height. Well, it's not even going to store 0 because we don't want 0, but it's going to hold 1 to game height, and Y is going to hold 1 to game width. So you can choose an appropriate type. Could Y location be 1.1? I don't think so. Okay, so you can choose the appropriate type. And then follow the flow diagram to write the next segment of code. I accidentally got that out. Okay, so now we get the flow diagram. And this is a bit of logic. Okay, so we have a big flow diagram. I'm going to grab the bottom of that. And up here is just step 12, I think, or step 11, yeah. So that's step 11. Okay, so if you go on LMS somewhere, what's LMS? There we go. You go to LMS and you go to week 7. We can see all of the things for a flow diagram. So we've got the symbols for a flow diagram. If this loads. Okay, so we've got all the basic symbols. One that a lot of people miss is, come on, hurry up. Why are you being so slow? Is the do while loop. Okay, so you notice that there's that little dot there. And we get that do while happening. Okay. So if we have a look at this, we have a bunch of conditions and we can break this down, okay? And this is how you should handle big flow diagrams. So we can see that this here, oh my God, what's going on? Okay, we can see here that all of this down here pretty much leads back up to here. Okay? And it goes through a bunch of stuff. But we can see that all of this oh, whoops, I didn't mean that. I wanted a little bit more of that. We can see this is just a big loop around this. So I've actually got this, some code that comes back up. Okay, so we can see that that is some kind of while loop. Okay, if we have a look at the while loop, flow diagram. This is a do while, we don't want that. Come on, hurry up. We can see that a while loop is basically just a condition, some code comes back, yes or no. Okay, and we've got the same thing here. Yes or no, and some code in here. Okay, so we can see that all of this is inside a big while loop. We can then also see here that this happens, we do some code, we check some condition, and we go back up. So we have a do while loop here. Okay. We can see that this and this never come back to themselves. So what is that type of condition called? Can anyone in the chat? Chat. Ah. That is a good point. So I don't actually tell you what a live is. I might actually fix that up. Yeah, so this is an if. So these are just if statements. Okay, I'll come back to the alive. Alive is based. Actually, I'll come back to it. This looks like an if. This looks like an if, and these just look like statements. Okay. So the flow diagram's not as complex as it may first seem. Always try and find the loops first. Now, alive is the global variable. Okay. Because basically that's what that global variable is doing. I didn't make that clear, so I might add that on the elements. Okay. However, you should be able to work it out. There's already someone that's finished. Well, actually, there's two people that have already finished the assignment, and they were able to work it out. So I think it shouldn't be too hard to work that out. Well, I will add it as a note. Okay. But that is the global variable, because that's what the global variable does. What do you mean, what? No. It's not about not having a life. It's that they're students that are stronger. And we have to cater to all of them. We don't want this subject to be boring. Yeah, people are finished. It's not an overly difficult assignment once you've understood the content. So, no, they're not master students, they're both undergraduate. All right. So, where are we now? Ah, it's not hacks. Yeah, pretty much. This assignment should take, if you know what you're doing, maybe 3 hours. If you're learning at the same time, maybe 6 to 8 hours. And if you're very good, maybe an hour or 2. And if the biggest thing is that the biggest mistake that most students make with these assignments is that they're not debugging themselves on the way through. And so they're the hacks that just try and hack it until it works. If you're debugging as you go through and you know what you're doing and you're not just following the steps, rather you're trying to understand it, you can get this assignment done fairly quickly. Okay. All right. So then we check the alive variable, which is the global variable. Oh my God, why does it keep happening? See if the user's won, you can print an appropriate message. Don't refer to the bonus, it's not a bonus anymore. Okay. It used to be last year, but it's not anymore. And then end the function correctly. I don't know why I gave you a hint there, I shouldn't. I'm too nice. Way too nice. All right. So what else do we need to do? Make move and get move functions. So make move. Actually, you're probably better off with get move first. I'll put it here anyways. But I'll get move as well. Okay, get the function that gets a move from the player that takes a pointer to the x coordinate, y coordinate, and flag. So you're talking about passing it by reference here. The max x coordinate and the max y coordinate. Okay, so where the hell my pen go? Sorry. There it is. Sorry. All right. So the max x and max y are kind of important. Remember that the max x is here. I mean, yeah, max x is here, max y is here. You've got this extra spot, but that's you can't access, the user can't access. So the max x, the max y is here. The min is always going to be 1, okay? And 1, okay? Is the minimum. This is the minimum, this is the maximum, this is the maximum, this is the maximum. So you can't go outside of that border. As we said, the game is inside of that boundary. Ask the user for X, Y, and flag. You've done this in lab 2. Store the location pointed to by the pointers appropriately. Yeah, just dereferencing. Continue asking the user if the locations are invalid. So if we had a 4x4 and the user enters 1003, you just keep asking them, because obviously you can't get location 1003. Okay, or if the flag is 8. Okay, so that's really easy. And then you got the make move. So this function takes the game information, the board information. Does that make sense? The get move function. There's nothing new in that. It's basically lab 5 and or less. Happy with that? All right, make move. So this function takes the game information, the board information, the location of the coordinate to be revealed. It tests if the coordinate is a mine or not. And if it is, it sets the appropriate variable, which is alive, obviously. So we've got our game board. We've got our play area, which is this. So some of the positions might have mines. If the coordinate has a mine, so if they entered 1, 1, set the appropriate bit to revealed. So make that revealed as well, and set that alive variable to 1. Else, set the appropriate bit to reveal the given coordinate. So if they entered, let's say, 2, 2 instead, this doesn't have a mine, so we set it to revealed. It will then show the number. So this, in this case, it will show a 2. If it's a flag, then we don't show. So if they enter a flag, then we don't set the reveal. We set this to flag. Why does that say? That's not quite well written. I'm going to fix that because that's not quite right. So if it's a flag, oh no, that is right. That is right. That is right. Sorry. If it's a flag, we handle that in main. So that is right. I just confused myself. So if it's a flag, we unset the flag bit. So if it was a flag, this is not a flag anymore. And then we change it to revealed. However, I've made a change, so this can actually never happen. But you still need to do it. Okay? It just protects the code. And if the value of the coordinate is a 0, so this one, then you call the function uncover zeros. Okay, so this is only a couple of lines of code, and that's pretty much stage 2 done. Stage 2 isn't very long. Okay, it's a little bit of following that, some really just getting a bunch of scanfs, and then just basically changing some bitwise stuff. And then we have stage 3. Now, I'm not going to give you much information about this, but I might have a quick break before I get to that. My mouth is dry. And then we'll talk about the last stage. And then that's the assignment done. All right, we all still here. Just reply if you are. What is one-time solution to crashing? Write your code correctly. It's always the best solution to crashing. Actually, the best way to avoid crashing is just safety. So if you write very safe code, so if you guard against, so generally most people crash because they go outside of an array. So if you always check that you don't go outside of an array, and you may have some macro to check that, you shouldn't crash. Okay. Usually that's where most people will crash their code. Assignment. Okay. So stage 3, uncover zeros. You meant browser? I don't know. I don't know. Turn off all your plugins. That's one solution, maybe. All right, function, uncover zeros. So, there is a couple of challenges here, but it is not very long. You can do this in about 10 to 30 lines. That pretty much means you get 1% per line nearly. This is worth quite a lot, okay? And this is testing your logic skills, your ability to engineer a solution. Because in this subject, we don't just want people that can follow orders, but people that can design solutions to problems. So this is worth quite a lot, and you can't get over 90% without doing it. So you should have a good crack at it. It is not very long. It's only a couple of lines. So you also don't need the size of the board. Okay. Now I've already given you a clue here in the fact that we use the fact that we've got these zeros that are revealed around the board to deal with this case. Okay. So if you find a 0, then any 0 that is next to it also gets revealed. Okay? So you uncover all the surrounding zeros. If this 0, if any of these zeros have a 0 next to it, you also reveal that. If this has a 0 next to it, you also reveal that. If this one has a 0 next to it, you also reveal that. So this is basically finding all the zeros. Okay, now that are touching each other. Now, we can go diagonal in our case. In the normal game, you can't, but I don't mind if you do either. As long as it works, I don't mind. If you decide to block out the diagonals, that's fine as well. So you can do this either recursively, which we've seen in the past, meaning you have a function that calls itself. Now you need to make sure this stops somehow. Okay, so you saw in one of the help sessions, and you can read about recursion. When we did, what did we do? Did we do? We did an example using, I don't remember. Can't remember. But we did a recursion example. And if you don't want to use recursion, you can do it iteratively. However, it is slightly harder doing it iteratively. Okay, but it may be easier conceptually, but it is a lot harder to get everything. Okay, and that's basically all this function does. Yeah, we did it ages ago. It's nothing special. Okay, and that's the uncover zeros function. Okay, and then if you do that, you can do the bonuses. Okay, so that's the assignment. So the first two stages don't include much that's new. They're kind of, yeah, fairly low in the terms of the weeks. It doesn't have files or anything like that, so it's not too difficult. But if you do the bonuses, it does. So let's get the bonuses up. So we've got three bonuses. We've got accept input from the command line and write to file. So we've done this before. You need to create a macro named bonus1, and then if bonus1 is defined, the assignment should do this. So this is kind of like how you were using the debug macro. Okay. So accept a file name, which is a string, passed via the command line. The program should check if there's two arguments. We did this last week. Everything that the user enters in the program is written to a file, and then handle the file appropriately, so like close it and all that kind of stuff. And you should end up, the file should like the test cases. It shouldn't like the test cases. It should look like the test cases. I don't care if it likes them or not. So if you have a look at the test cases, I'm going to open that on the screen. So we get a test case on. Actually, why can't I open that in the browser? No, it's not allowing me. I can open it with. Anyways, I'll get that up in a sec. Let's have a look. it should look something like this. Okay, so it has the width, the height, the number of lines, and then all the moves that the player made. Okay, so if you did it right, it should look something like the test cases. Then bonus 2, anti-CSI codes, overwrite screen. So this is a bit of a more of a research task. So read the Wikipedia article. So we go to Wikipedia and we read all this, which is all really cool and fun stuff. Okay, we can learn about. So the main parts are going to be the sequence elements. We don't care about non-CSI, we care about CSI codes, and then all this. Okay. All right. And so basically what you want to do is clear the screen and overwrite the screen. Okay, so you're moving the cursor on the screen so that you end up not going down the screen like you are now. And the last one is adding color, which isn't too difficult if you can do the one before. And you're just basically creating these colors for all the flags and numbers and all that kind of stuff. Okay, and that's the bonuses, and there's 6 marks there. And that's assignment 3. What do we think? We're all going to kill it now. Do it slowly. Do it using a piece of paper. Use your box and pointer diagrams. Use your debugger. Debug as you go using a debug macro. You should be fine. If you're just rushing into it and guessing, that's the biggest problem, and that is what slows people down. Okay, if you take it slowly, you should be able to do it quite easily. If you just rush into it and guess and just chuck a whole bunch of ends and stars and loops and random stuff, which I see so many of, you're just going to fight until it works. And if you fight until it works, you're just wasting time. Use your debug macro, hash define, debug as I showed you. Use GDB. Use your box and pointer diagrams. You don't need fancy looking diagrams. You can just do quick sketches of your diagrams. Use your flow diagrams as well. Draw your own flow diagrams. Make sure things make sense. Right?